worksheet 0.5. I know some of you have already turned this in. I have it from maybe a select few people, other than the ones who turned it into me personally right now. So I'm going to read off the names who've already done it in case you don't know. Okay, so I got it from AJ, got it from Ryan, have it from Eric, Ben, I got it from Mason, Alexis, Donna, Maddie, and Ed. So if I did not see your name, you have not turned in 0.5, that was the multiplication one. I'll take that, some way you put it in the back front, where you want to put it. So I'll collect that, I need those today. Okay?
I thought it was due tomorrow.
Oh,
You said Thursday.
Yeah, isn't it Thursday?
No, you said Wednesday.
No, you said Thursday. You said Thursday.
You told us
You
Thursday.
did say Thursday because after you said that, I wrote it on the paper. On my worksheet.
I'll take it
said
tomorrow.
Thursday.
So you're lucky you got one more day for it. So, all right. Now, next thing you need to do, get out your Chromebook, log in. Get out your Chromebook, log in. You have 5 minutes to complete the 5-minute challenge kind of a thing. I'll give you a little more time if you need to. You can use a piece of paper separately with notes. No partners, no calculators, nothing like that. It's 11 questions, something like that. You're going to fill it out, just multiplying. So you can use any form of math you want. So if you want to do your column method, if you want to do the little lattice method, go through it. Try to do the best you can. I think it's just multiplying by 3s. That's what it is. So it's easy, smaller numbers. I want to see what you get for your answer. You need a separate sheet of paper to do that. I'm not going to collect that separate sheet. You've got to submit it. Make sure you're logging your school email and that you're filling out that form. I'm going to do about 5 minutes from right now. I'll put a little timer on the clock. And then hit submit. So I want that before we start today.
Is this green?
I just want to very best.
What are you doing, Don?
Hit submit and get your notes ready to go. Just make sure you hit submit before you exit out of there. Hit submit and close your Chromebook. Get out your notes, be ready to go for that.
What'd she get?
keep talking right now. Perfect. All right, so thank you for doing that. What was that? No, just kind of want to see where we're at. I try to do those mental challenges every once in a while. Kind of get you prepared again for what we're doing. We're multiplying and obviously dividing. We started multiplication, what, 2 days ago, something like that? Today we're going to continue on with that same topic, but we're going to do it a little bit differently now. And I want to show you the concept of what we're doing, okay? All right, if you have a multiplication chart, I would definitely take that out now. Now, if you need one, because I had those big copies, if you want one of those today, it may not be a bad idea. So, does anyone want a multiplication chart? Okay. Not a big deal. If you want one, definitely have it out. Take it your notes today. This will kind of help you out with the idea of what we're doing. Anyone else want one? Okay, here you go. But yeah, I could get this. Okay. Anyone else want a multiplication chart?
Like a dog.
Danger, you said you need to go. All right. Okay, so we're out of here at 9:37, so we got about 20 some minutes or so. If you have a multiplication chart or something like it, or maybe you just know kind of what some of these numbers are. Our goal today is to look at division for the first time. A little bit different than what you're thinking. We're not going to do long division or anything like that today. We're going to be doing something a little bit different that will hopefully help you out. So here's the idea. If you look at your multiplication chart, just you happen to know, what's 3 times 6? 18. Okay, so we've talked about multiplication, right? That on these smaller numbers, you just actually have to know it, right? It's one of those things you just have to have memorized, basically the numbers through 9. Because after that, you can either do lattice method or you can do column method if the numbers are 2-digit numbers. But when they're single digits, you kind of just have to memorize what numbers multiply together. And so when it gets to division, by knowing these simple facts, it makes it easier to figure out, because when you're dividing, right, and you're taking 18 divided by 3, you're actually trying to figure out what number multiplies on 3 that gives you 18. So the answer is 6. That's what you're doing. You're actually going backwards, because here's what it's doing. It's taking this problem, and it's just moving this 3 to the other side. And when you move a number to the other side of the equal sign, it becomes the opposite operation. So if they were multiplying by 3, when you go to the other side with the 3, you divide by it. That's called an inverse operation. Well, that's why it's helpful, like in division, to know those really simple math, those math factors, right? What numbers multiply to give me this bigger number? So that's why memorizing through 9s is actually a clever thing. That's why, like in elementary school, they have you do flashcards a lot, and you're trying to memorize or do like, I think they called it what, rocket math, maybe in like elementary days, where you had to do these big sheets of like 50 problems. You had to do them as fast as you can and see what you can do. Yeah, because they're trying to get you to memorize really short, like quick facts. Some people are good at it, some people aren't, just because there's just a lot of them. It's daunting when you first look at that page. But they're trying to get you to this point where you can eventually figure out, okay, what number goes with 3 that makes 18? Well, it's 6, right? It's trying to get you to memorize these facts. Well, what we're doing today is doing something slightly different. We're not doing long division. What we're going to look at today is the actual idea of rational numbers. We're going to look at that concept that we brought up a long time ago, maybe a week ago, rational numbers, or anything you can write as a fraction. Right? So anything written as a fraction or a decimal that repeats or ends. Fractions are our key concept today. And so we're going to introduce the concept. We're just introducing the easy stuff. So here's the part I want to look at today. I want to learn how to simplify a fraction really fast. Like, what is the easiest, shortest way to do it without stressing you out? Second thing I want to make sure that you know how to do is know what a mixed number is, or improper fraction. I want to show you this concept and kind of explain it in the easiest way that I can for you. And hopefully it'll make more sense, and I'll give you a visual aid tomorrow for it. But I'm going to try to explain it the best way I can. So this is our goal today, those two concepts, right? But it really comes down to like the idea of like division, because that's what fractions are. It is literally just a weird way of showing division on paper, just using a weird symbol, right? So let's say we had a fraction. I'll just kind of pick an easier one. Let's go 4 over 12, right? It's a fraction. Now they could write this fraction different ways. They could write like this. They could put the line slanted. It means the same thing, but what we want to do is we want to simplify this fraction down, get it to its simplest form. So the idea is that what you can do is you can simplify both numbers at the same time. And the trick is to figure out the numbers that they both have in common like as fast as you can. So here's how I do this. This is the easiest way I've learned how to do it over the years. Instead of trying to like go, okay, what goes into 4, what goes into 12, because most people don't like that. All I want you to think about are what are two numbers that multiply to give you 4? 2 and 2? Does everyone agree 2 and 2 goes into 4? Okay? So 2 times 2. Don't even think about it, like just easy numbers. Now obviously you could go 1 and 4, but 1 goes into everything, so try to pick different numbers. And now what are numbers that multiply to give me 12?
6 and 2.
6 and 2. Okay. You could go the 3 and 4 route if you were that person. Okay. It doesn't matter. So notice what I wrote down. Now, if you can break up any of these numbers further, do that. So like 2's you can't break up, it's 2 and 1. I don't really want 1's anywhere. 2 and 1. But what about 6? 3 and 2, right? That multiplies to give you 6. So I'm going to break up that number even further. So this is the same fraction. All I did was break up the 6 even further, and that's what you're seeing there. Okay, does that make sense? I'm breaking down the numbers as fast as I can without thinking about it. I just want to write down every number that multiplies to give me that number. And not every factor, just the first two numbers you can think of. And then if you can break them down further, go from there. At this point, this is the easiest way I've learned how to simplify fractions. Is that I've written down all the numbers to this point, right? I broke it down as far as I can. And all you need to do now is cross them out if they have anything that matches top and bottom. So is there anything that matches top and bottom? 2's, okay. And there's another pair of numbers that match, another pair of 2's. So I'm going to cross those out. And so your final answer is going to be a fraction where there's a 3 left on the bottom, because there's still a 3 down there. And on the top, since we don't have any numbers left on the top, you can always put a 1 up there. 1 goes into everything. There's your answer. This is the simplified version of that. It's the same fraction. So what that means is if you scored a 4 out of 12 on the quiz we just took, because it was what, 12 questions out of 11? I think I saw there was 12. So let's say you scored 4 out of 12. No one did, by the way. Let's say you scored 4 out of 12. That's the same as taking a 3-question test and only getting 1 out of 3. That's literally what that's telling me. Or, if you were the person that got to here and you forgot to break up the 6 even further, and you crossed out these 2's because they had 2's in common, and you wrote that your answer was 2 over 6, that's the same score. 1 out of 3, 2 out of 6, 4 out of 12, they're all the same score. So that's why, like, when I give you a test or a quiz, I don't need to give you a 100-question test. I don't need to give you a 50-question test. I can get away with giving you 20, maybe less than that, 15 questions. Just depending on what the quiz is, because I can simplify the problem down, simplify the fractions to figure out what is the bare minimum numbers I need to give you so that you get the same score in the long run. So I can minimize the questions on a test. Okay? It was one of those things. Now, it is better to have more questions, so you get more chances of opportunity to give the right answer, but sometimes it's not worth it when you can get the same score by cutting the numbers down. Okay, that's the concept. So, it may not seem It may not seem like it, but it's one of those things like once you learn how to do this like really quickly, this process of simplifying fractions is really fast. Now, obviously, calculators can do that for us. Like these calculators, these scientific calculators that we have, can actually simplify a fraction for you. They have little ABC buttons. They can do fractions for you. That's something we're going to eventually look at after chapter 1. Like we're going to come back and learn how to use this technology and your cell phones and whatnot, so that it can do math for you. Because I mean, that is a skill you need to learn, right? In the real world, you have a cell phone with you. It can do fractions. It can do other things for you. So that's kind of nice to learn. Okay? All right, does that make sense what we're doing?
Yep.
Okay, now, this is just the first one, right? You're breaking numbers down. Let's do one more, and then I'm going to talk about the other idea of mixed numbers and improper fractions. So let's do another one here, and let's try to go through it where we just do it as simple as we can. So let's say my number was 18 over 24. 18 over 24. It's a bigger fraction, but I want to simplify it, right? And I don't want to just like randomly guess. So here's what we're going to do. We're going to do it the same way we just did this one. All I want is somebody to volunteer, raise your hand, if you know two numbers that multiply to give me 18. So, Dar, give me one.
9.
9 and?
9.
9 times 2.
2. Oh, yeah.
9 times 2. Okay. I'll go with that. That's good. Okay, give me numbers for 24.
Oh, 24, 12.
12 times 2, okay. Does that make sense? Now, it didn't matter which numbers you picked, because obviously some of you had different numbers in your head, right? For different answers. It doesn't matter. That's the beauty of doing it this way. It doesn't matter if you had different answers. The math will all work out the exact same way, and you'll get the final answer the same as somebody else. That's the beauty of it, because you were going to pick different numbers for 18, right? What were the numbers you were going to pick?
Like, 6 and 3.
6 and 3. You'd still get the same answer in the long run. In fact, I'm going to prove that fact. So if you were the 6 and 3 person for 18, maybe that's the numbers you thought of. I'm going to show that it's going to be the same math no matter what. Okay, what about 24? Instead of going 2 and 12, 8 and 3? Or what's another number? 6 and 4? Okay? So it doesn't matter which numbers you pick. If you want to put 6 and 4 down here, you do that. The answers will be the same, and I want to show you that. You just need to see that we can get to the same answer. Okay, now, I'm not done yet. Let's keep breaking these down further, right? So, how do I break down 9 even further?
3.
Okay, 3 times 3. That would be the same as 9, so I'm breaking down 9 even further. What about 12?
6 and 3.
6 and 2, or what, 3 and 4? However you want to do that. So, what I've done is I broke down 12, and I broke down 9 even further. You can see that's what I did there. Now, I'm not done there. I still need to break down this 6 even further. This 6 can go down one more step. So, what I have here is I'm breaking down that 6 to be 3 and 2. I still have a 2 and another 2 down there. So I broke down this 6 even further on the bottom. Okay, does that make sense? On the other problem over here, I'm going to do the same math. So I'm going to break down the 6 here. This is 3 times 2. And there's still a 3 left on the top. Down here, 8 is what, 2 and 4? So I'm breaking down 8 to be 2 and 4. And then the 4 breaks down even further. So this 4 can go down one more step. So here's what I have on this one. Yeah, so I have 2 and a 2, and then there's still a 3 down there, so that's breaking down the 4 even further to be 2 and 2. All right, now, what we do, if you notice, the fractions are the same. It didn't matter which numbers you pick. As long as you're breaking down these answers, you're going to get to the same number as somebody else, because you're going down as far as you can. And then all you have to do is cross out numbers that they share. So, up and down, like pairs of numbers. They share a pair of 3s, they share a pair of 2s, and that would be it. Like that's all they have in common.
So it's 3 and 22.
So, on the top, what do we have?
3.
We have a 3 left on the top. Okay, on the bottom, we have 2 2s, which is 4. There you go. This is the same fraction. So, instead of taking a 24 question test and getting to 18, you could have taken a 4 question test and got 3 out of it. And it would have been the same score in the grade book. Now, again, how I got the 4, there's still 2 2s on the bottom. You still multiply that together, because I couldn't cancel these out, so those had to stay down there. But that's the same over here. I would have canceled out 3s, I would have canceled out a 2. It would have been the same answer. It would have been 2s and a 3 on the top. Does that make sense? Simplifying fractions. It's one of those things like, once you see it, it's really straightforward, but you really have to like pay attention to what I was doing there. you have to know what numbers multiply. That's why a multiplication chart in front of you, if you had a multiplication chart, you don't even need to think about those numbers. Just find 18 on this chart somewhere, and then just use the numbers from the chart that made 18. That way it's breaking down these numbers, and you're using one of these, and it's really quick. There's other ways of teaching you how to do this, like other methods. This is by far the fastest way I've ever learned how to do it. And it works every time. You don't have to even put any real mental effort into it. All you have to remember in the end is crossing out numbers top and bottom. And if all the numbers cross out, you're putting ones in certain spots. Okay, questions with that? Okay, hopefully you have both of those examples written down. Okay, now, let's get to our next topic here. Next topic is going to be mixed numbers and improper fractions.
Hey, Mr. Ward, man.
Like a dog.
Yeah, let me do that. Okay, here you go. Boom.
Sixth grade.
All right, so let's walk through improper here. Okay. All right. So we've done simplifying fractions. We'll do some more of this tomorrow. We'll do it the same way as this. I think that's the easiest way to learn it. All right. The next topic. This is our last topic of the day. It's to look at improper fractions and what mixed numbers are. Okay. So I'm going to give you an example of each. So here's a mixed number. Okay, a mixed number is any time they put a large number out front and they put a fraction behind it. That's a mixed number. It's mixing a whole number, like a natural number, and a fraction, a rational number. It's a mix of both, a natural and a rational, but it's one number, it's 5.5. Now, an improper fraction is where they make the fraction so it looks goofy. That's why they use the keyword that it's improper. The top number is larger than the bottom number, which looks goofy. That doesn't look normal, right? That's an improper fraction. It's written wrong almost. It's improper to look to see that, because usually you're used to always having the smaller number on the top. I'm going to show you today what this is actually telling you. Some people never really learn the concept. They never understand what is this. Okay, imagine I'm going to use brownies, like food. Most people can understand that. So imagine on this example you had 5 full pans of brownies. So here's a pan, here's a pan, here's a pan, a pan, and a pan, right? You had 5 full pans. The last pan, which is technically the 6th pan, only has 1 piece out of 2 in it. 1 piece out of 2 is left in that. Now these pans are full pans. I'll just shade them in. That's what you're looking at. 5 full pans and a half left on the other, 1 out of 2 pieces. But what you're looking at over here, this is the easiest way to think about it. You have 1 pan, right? This represents 1 pan of brownies. It's just 1 fraction, right? There's not a whole number out front with full pans. It's 1 pan, but in this, normally it holds 2 pieces, 2 pieces of brownies or whatever it is. But for some reason, you've stacked 11 on that pan. You stacked 11 brownies on it, so they're just stacked, piled up. Okay? If you were to take those brownies, all 11 of them, and start divvying them up, instead of putting them in 1 pan, actually separate them into their own pans, you would eventually figure out. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So all these pans were full. I took all 11 pieces, put them into their own pans, and what you're going to figure out, it's the same number. That number and this number are the same. But it's the way you look at it, right? This makes sense to people. Having 5 full pans and an extra half, that doesn't make sense to people. You're stacking them into 1 when you should have used separate pans, so you can go back and forth. what I want to look at is how do they do that? What's the easiest way to do it, other than drawing stupid pans everywhere, right? That's the concept. It's literally counting. Where you'd actually see a normal improper fraction in normal situations, like in school, it's when you get extra credit, right? You took a quiz, you scored 11 out of 2 because you did a bunch of extra problems on it. Maybe you showed work and you got extra points for showing work. You know, that type of thing. That's a normal situation where you probably see it. But this is kind of the visual representation of what 11 out of 2 means. Okay, question.
What's the difference between a proper fraction and
A proper fraction is when they do something like earlier what I gave you, like the 18 over 24. That's a normal proper fraction.
Oh, okay.
The top number is smaller than the bottom.
Oh.
That's a normal fraction that we're used to saying. Like in this situation, you don't have any full pans of brownies. You're actually short. It's one pan, but out of 24 pieces, right, out of 24 pieces, you only have 18 of them. So there's 24 brownies, right, that can fit in a pan, you only have 18 filled in. It's different than the other one where I had multiple full pans. Does that make sense? Like
Yeah.
proper versus improper. Okay. That's what I'm going to cover today. I just want to show you an example. Tomorrow we're going to do more, I'll give you a visual aid tomorrow for that. It might help you out to see this a little bit better. But tomorrow we're going to look at how do we go from one to the other. We'll look at simplifying fractions. Multiplication charts. If you have one, hold on to it. Like if I accidentally handed you one today, I want you to hold on to it. I want them back today. Keep them for tomorrow. You're going to want it. If you want one, or you know you're going to lose it, I'll take it. But hold on to it if I gave you one today. Be ready to go tomorrow. Okay. Tomorrow is your last day. I'm going to take that worksheet 0.5. I probably give you an extra day than what I normally said. So you have one extra day to get that 0.5 worksheet turned in because it's going in the grade book tomorrow. So if you don't turn it in, you just get a score for it. And the midterm is this Friday.
Like now, insurance
I think it's 10. You want to double check?